Hi everyone, I am Aishwarya DT. Today, our topic is design and implementation of lexical analyzer and a parser for a mini ATC language. Next, we will see the aim and objective of our topic. So the aim of this project is to design and implement a lexical analyzer and a parser for the mini ATC language using a context-free grammar. The system checks whether the mini ATC project is grammatically correct or not. The objective of this projects are to identify tokens from source code and to perform a lexical analysis and perform syntax analysis using a context-free grammar, and also to validate the structure of a mini ATC program. Next, coming to the introduction, Mini ATC is a simple programming language used to understand a compiler design concepts. This project focuses on two important compiler phases. First one, lexical analysis and syntax analysis. The lexical analysis converts the source code into tokens, and then parser verifies whether the token sequence follows the grammar rules or not. Coming to the mini ATC language topic, in that mini ATC language follows a simple structure which begin statement list and which supports a declaration statement, assignment statements, and a print statement. This simplified language helps in understanding the basics of a compiler construction. Next, coming to the lexicon analyzer and a parser design, we will see how it is and what it is. So the lexical analyzer scans the input program and identifies the tokens such as keywords, identifiers, operators, and numbers. And the parser receives these tokens and checks whether they follow context-free grammar rules of a mini ATC. If the system is correct, the program is accepted. Otherwise, the syntax error displayed. Next, coming to the tokens and rules that should be followed while lexical analyzer and a parser design going. Tokens are the smallest meaningful units in a program. In the mini ATC language, it contains keywords, identifiers, numbers, operators, and delimiters. The parser uses the CFG rules such as program, statement, and assignment. Program means begin statement, list, and statement means declaration, assignment, and print statement. Assignment means ID is equal to validate. Next, coming to the regular expression. This regular expression is used to recognize the tokens. For example, identifiers start with the letters and may contain digits. Numbers contain only digits. And operators include plus, minus, multiplication, division, symbols. Means there are some regular expressions which called identifiers, numbers, operators, and delimiters. In identifiers, it contain only letters and digits, and in numbers it contain only a digit, not other will be present, and in operator it contain plus, minus, multiplication, and division, in delimiter semicolon, brackets, etc. These expressions helps the lexical analyzer identify valid tokens. Next, coming to the DFA for identifiers and numbers. DFA stands for Deterministic Finite Automata. The DFA for identifiers checks whether the variable name starts with the letter A and contains valid characters. The DFA for numbers checks whether the input contain only digit. These contain major difference, like in identifiers it checks whether it contains letters and valid characters, but in DFA for numbers it checks whether it contain only a digits. These DFA diagrams are used during a lexical analysis for token recognition. For example, you can see For DFA identifier, it starts with a letter and accepts letters and digits. For example, X and value 1, it contains both letters and digits. Next, coming to the DFA for numbers, it accepts only a digit. For example, 10, 250, as I given in a slide. Next, coming to the implementation part, here we implemented using three files called main.c, lexer.c and parser.c. The main file controls the execution and the lexer performs the token generation and the parser validates the syntax. The process includes reading input, generating tokens and parsing tokens and displays the result. The working steps which contain read input, generate tokens, parse tokens and validate syntax. Next, coming to the sample input and output. So this slide shows the sample of mini ATC program. A lexical analyzer identifies the tokens and parser checks the syntax. Since the input follows all grammar rules, since the it contain it use the grammar of grammar of CFC. Grammar of a CFC, the output displays program is grammatically correct. For example, you see example in a slide. Begin int x is equal to 10 and print x end. Here it has a valid case of grammar and it follows the rules. For example, it also contain numbers, digits, semicolon, bracket, etc. All rules are included in this program. So automatically the output will be program is grammatically correct. So it is a valid case. Next, coming to the test cases, in that page we will see the valid and invalid cases of this topic. So we tested a program using a both valid and invalid input. In first case, valid program, in that it contain, as I told before slide, it contain numbers, digits, brackets, semicolon, all in this program. It follows the rules, so the program is grammatically correct. So it came a correct output. Next, coming to the test case 2, in that semicolon is missing. You can see there x is equal to 10, in that there is no semicolon, so it will show that syntax error. So these are two test cases, which is valid and in another one is invalid. Next we will see the conclusion part. In conclusion, the project successfully implemented a lexical analyzer and a parser for a mini ATC language. The system correctly identifies token, validates CGF, and nothing but CGF rules were validated successfully and also detected syntax errors effectively. This project helped in understanding important compiler design concepts. So these are the references used for this project, which include compiler design textbooks, automata theory notes, and CFG and DFA study materials, etc. Thank you.